Welcome to this week of Introduction to Java. In this week, we are going to study everything about object-oriented programming within Java. So, to recap, what we studied in last week was totally about the basic constructs of the Java language, like variables, data types, operators. We also saw some different statement types like selection statements, iterative statements, and method calling. We also saw how we could use arrays and strings as well. Now let's come out and look at Java from a bird's eye view. From a bird's eye view, Java is definitely an object-oriented programming language. Now let's look at what is object-oriented programming language and what all principles are there. Remember that this week is extremely important because if you say that I know Java, then you will be questioned about all the object-oriented concepts and you should be well versed with them. Now, in this week, we are going to study everything about classes and objects. We are going to study what are constructors and how they are used. We are going to study the this pointer and its importance. Then we will look at what do we mean by the static keyword. You remember we use static keyword a lot, right? Especially with main. And we will also see how we can use final keyword as well. We will see then how we can give different permissions to different variables to be accessed from different places. Those are known as access modifiers, and that also really helps Java become so secure. Then we are going to see one important principle of object-oriented programming, which is inheritance, which is also called as an is a relationship, or we are going to see another principle, which is composition, which is called has a relationship. Then we're going to see what are abstract classes and what are interfaces. And then we're going to see another very nice flexibility which Java programming language provides, which is method overloading and overriding. And then we are going to look at another principle of object-oriented programming, which is polymorphism. And lastly, we will cover all the remaining aspect of object-oriented programming by making you understand that whatever I have done, how that actually is encapsulation and abstraction. So now let's begin with classes and objects. Now, what really is object-oriented programming? As I told you that earlier, programming used to be very procedural. That was known as procedural programming, in which we always focused on the procedures of the tasks which we are doing. Given any data, what procedure and what things I have to do to accomplish that task. So it was created using different functions, and each function would do certain tasks on that particular data, and the data would be freely flowing from one function to another function. There is no security in this. What object-oriented programming paradigm says is that imagine you're programming just like real life. In real life, we have different objects, right? In real life, the world is not created just using procedures. The world is actually created using real life objects. Each object would have certain properties and each object would have certain methods of doing certain things. Why not encapsulate that? Put all of that information into a particular capsule, put all of that information in a place which would define the type of object, all the variables of that object, and all the information and all the methods which this object would use. For example, we can say a dog. We could have different, so let's consider one object in this world is, let's say, a dog. The dog would have a species, dog would have a height, a weight. The dog would have methods like moving, barking, sleeping, etc. So why not put all of that information in one capsule, and let's reuse these different capsules to make, let's say, more and more dogs, to assign all the dogs different names, and then finally be able to understand which dog is moving, which dog is barking right now, that particular dog's color is what, and that particular dog's breed is what. So that is the whole idea behind object-oriented programming. Now, object-oriented programming really helped us to actually think in the sense of objects and have a lot of security and a lot of robustness in the programming language. Also, object-oriented programming paradigm helped us in making it very, very maintainable, because not everything is exposed to public, not everything is exposed to any other software developer who would want to change or use our code and extend our code basically. So that really gives us a lot of flexibility and a lot of maintainability in terms of writing and maintaining code. For classes and objects, I'm going to create a new file, which is going to be a Java class. and that's what we are going to understand what it is. So I will name as class objects. Now here, as you can see, one class is created. Okay. Now what class exactly is? Class is just a skeleton, a blueprint of another entity, which is its object. So you can say that class is just an idea of how things are. For example, a human being is just an idea of how a man or a woman would be. But then you and me, with our own names, are actual human beings who are living in this world, right? So human being would be a class, but you with your name is the object of that class, and you are actually the one who's actually existing, and you are called a human being with so and so name. Similarly, we would have a class, but then this class is just an idea. It is just an idea residing in the Java memory. When I create an object of this class, only then I would say that an entity exists of this particular class. So what we would say is object is an entity of the class, or you can say in a better word, an instance of the class. So object is an instance of any class. Now in this, we used to have main, right? So I'll just include main over here, and let me create another class of name vehicle. Now every class would have two things. One is variables, which we already studied, and another is methods, which again we have studied. So for example, for the class vehicle, logically, what do you think each vehicle has? Let's say the vehicle has a color, so I would say string color. Every vehicle has speed, so let me just assign that to an integer speed. So let's just keep these two things out here. Now these two things are the variables of the class vehicle, and then it could have a method. For example, move or drive. So drive can be a method, and right now let me just create it to be public and not return anything. And drive is just, let's say it's just printing that I am in motion. Okay, so now this way we can have multiple methods. For example, we can write a method called stop, which again we would put public, and this again will just say that I have stopped. Okay, now let me just rename it to start. Okay, now this is how vehicle class is, but now I just want to create an actual vehicle. Let me just create an object of this vehicle. And how would I do that? I would do that using the new keyword. We have already seen how a new keyword is used, let's say, to create a string object. Similarly, for vehicle, we can create an object. Let's say I would say vehicle car equal to new, and then I would write the class name again. And remember, the class name always begins with a capital letter, and then round brackets. Okay, now this is actually going to create the car vehicle. Now remember that your variables as well have to be shown whether they can be accessed or not. So if they are public, we would just write public, but we can also add other access specifiers or access modifiers as well, which we are going to see later on. But right now I'll just keep all of these public, and let us just try to assign car dot color equal to, let's say it's a white car, and we would say, let's say car dot speed equal to, let's say 200 kilometers per hour. And this should not be a string because it's supposed to be integer. Okay, and let's call car dot start. Okay, once I save this and when I try to run this, it says I'm in motion because we just started the car. Now let's create a special type of method which is known as a getter. Okay, Now getter means that if I want to get something from here, so I could actually access it using class.color, but I could also have another method which would help me access this color. So I would say public string get color, and this will simply return color. And similarly, I could have a getter for speed, or in an easier way, we could have all the getters of all the variables in a class using the Eclipse functionality. I would just right click, I would simply go to source, and I would go to generate getters and setters. I would click on speed because that's not something which we have right now, and then I would say generate. So what it did is it actually generated a get speed method for me, which is the getter for the speed variable. And similarly, we can have setters as well. So when I right click and when I go to source, and again, we click on color, and then if I generate, you can see that since I already have the get color method, what it did is that it created a set color method for me. Since we already have the get speed, since we created getters and sisters for speed, we already had the set speed as well. So now I can simply use these getters and setters to get the speed for that. So I would just use the object name. Remember to always use the object name or the instance name. Object is also called an instance, right? So I would just use the instance name to call that method. So we would just do a dot get color, and that color would be returned to us, and we can do something with that color. So I would just print that for now. And similarly, we can get speed and print that. And when I run this, you can see white 200 and I'm in motion just because I try to print the color, the speed, and execute the start method. And similarly, to complete this, I can execute the stop method as well, and this would simply say that I have stopped. Okay, so these are the basics of classes and objects and how we can create another class. We can have variables in this, we can have getters and setters, and we can simply call them from our main method. In fact, we can call these from another class and its methods as well. It only determines if we can access things from this class or not based on what access specifier which we have mentioned. So now everything is public, so we can access everything from another class as well. So I could actually access everything from class vehicle in my class objects just because everything was public. As you can see over here, this is class objects.java, and we just have one public class out here, which is class objects, and that's the same name as the file, but we can have multiple other classes in the same file as well. You already saw about class and that we have variables and methods in it. So variables are also called data members or data member variables, and methods are also called member functions. So this is something which can help you work with classes and objects from now. But there is one very important aspect which you should know is that whenever any object is created, so here we try to create an object car. So what happens is that this thing is called using the new keyword. And what is this thing? This thing looks like a method, right? Because it has two round braces over here, and round braces always denote methods, right? So what is this method which is called? This method which is called to initialize this car object is known as a constructor. So to show you everything about constructors, let me create a new class called constructor. And now over here, I'm just creating my main method again. And over here, let's just create class called as, let's say, attendance. And you would have attendance in classes, right? So here, let's assume that we have our student count and we have our subject. And then probably we can add getters and sisters over here as well. So let me just have these two as public right now. So I'll select all, generate. Okay. Now let's create an object of this class attendance. So I would just write attendance, and let's assume that every time an object is created for this class, meaning we want to enter a particular class, any student wants to enter a particular class. So I would just write enter Java, because let's say the student wants to enter the Java class, and this object would be created, and then using enter Java we can assign the student count, the class name as well. Now think logically. When you actually create a new object, you are calling a particular method which you cannot see over here, but is created by Java to actually initialize this student count and class name. Now, what do we mean by initializing? Initializing an object means that memory is assigned to all its variables, right? So memory is assigned to student count, and memory is assigned to class name as well. Now, once memory is assigned, you can simply assign some value to it. So I can just write enter Java dot student count equal to 1. Okay, and what I want is that every time this object is created, the student count should increment. Okay, so now the student count becomes 1. So why not have a way in which I can initialize it in a better manner? So what I want is that I want to actually redefine this constructor, not the default one which Java provides, but I want to actually write a constructor myself. I would just use the same exact name of the class, which is attendance in my case. And here we can simply assign what is the initial student count and what is the class name. So for example, the student count initially, like the first time this object is created, the student count really becomes only 1, right? So that's the thing. Now, what about the class name? I want different classes, right? So this is a default way in which, our attendance object can be initialized. So if I just do in enter Java dot student count, and if I just try to print this, you can see that now I'm able to print the student count which is created. But I want to assign the class name as well. This means that student is entering the Java, means the class name is supposed to be Java. Well, how can I assign the class name over here? To do that, we can have attendance, and then we can pass some parameters out here. So let's say I want to pass an integer, which would essentially add to the count, and I want to pass in the class name as well. So I would just write string class name. Now over here I would say student count is equal to the count which I just passed, and class name is actually equal to the class name which I just passed. And we just save this. Now can you see this yellow line over here? The assignment to variable class name has no effect. Why? Because you're just essentially assigning the same thing to the same thing. How does it actually know that this is my instance variable which I want to assign, and this is the local variable of this method? To do that, we have a special type of pointer which is known as this pointer. We can just put this dot class name out here. What this would say is that the class name without the this pointer is actually the local argument of this method, and with this pointer, what it means to say is that for this object and its variable class name, I want to assign this local variable over here. So when it says this dot class name, it means that the variable class name of this object. Okay. So once we do that and we save it, when we try to now create the object over here, let's say with one Java, and let's try to now print the class name as well. And this is supposed to be a string constant. So let me print this. So now it says one Java. Why? Because the student count is set correctly to 1, which we passed over here, and the class name is set correctly to Java. Let's say another student wants to enter the same class. We would simply write now the count becomes 2 and the class is Java, which the student wants to enter, and the name can be, something different because otherwise it is giving a conflict. So when we try to run this and we try to use the second object which is created over here instead of the first. Now let's try to print this. Let me just correct the name. So now we have 2 students and Java, which is printed over here just because I sent 2 and Java out here. So now this is how we can create a default constructor. This is known as the default constructor, meaning which does not have any parameters. And the other one is known as parameterized constructor. There's one more type of constructor which you should know, and that is known as the copy constructor. So what we essentially do is that we want to have that kind of flexibility that, I want to actually create a new attendance object, but I want to actually just copy another attendance object A and just initialize my variables from that. So I would say this dot student count from A dot student count, and I would say this dot class name from A dot class name. Now what this will help us do is, if we have a new construct, if we have an older object and if I just want to create another object based on this old object, I can simply pass enter Java, which is the old object out here, and we would have enter Java 1 created out here. So when I save this and when we try to run this now, you will see 1 Java. Why? Because the older object was created using these values 1 and Java, and now when I try to create a new object just by passing the old object, then I'm getting the same values from here just because of this copy constructor. Now you may even have different versions of constructor. For example, I just want to mention the class, that's it. I don't want to actually now mention the count of students. So for that, let me just, put this dot class name equal to class name. So this will really help me to actually initialize it with just the class name as well. Now, it may be that instead of writing this, I can just want to call this particular constructor. This is known as constructor communication. So I just want to show you what is the meaning of constructor communication. I want to say that this constructor can be called by another constructor. So if instead of this, I just call this and put the class name out here. So now here, this is giving an error. The reason is that it says constructor call must be the first statement in a constructor. So that means whenever we want to call another constructor, we have to just remember that that should be the first thing we do. So first we call the other constructor to assign the class name, and then we assign the count over here. When I save this, and then when I run this, you can see now there is no issue. Why? Because while creating enter Java object, I just sent the number of student count and the class, and it called this particular constructor, and for that it first called this constructor, that is constructor communication happening over here, and it assigned the class name to this dot class name, and now here we assign the count to student count. So this is how we have done this constructor communication. If I just use the older one instead of the new object and print that, again, we'll have the same thing. So that's not a worry for us. Now in our place, every time we create a new object, the student count should increment, right? So before even creating any object, I just want to make sure that the student count is equal to 0. Now, if I just do something like student count equal to 0 after, let's say, all my constructors are defined. So I just want to write student count equal to 0. That's it. And I want to save this. But here it is giving me an error, and it says that, it is actually expecting something else. The reason is because whatever operations we want to do, we can either do it within the constructor or within methods, right? If I just want to do an initialization out here, we need something known as the initializer block. So I would write over here initializer block just to show you that with an open curly brace and a closed curly brace around this, now we do not have that error, and this is actually going to initialize our student count to 0. So once we do that, and whenever we create a new object, this student count will then become 1. So this is how you can use, or you can write any other initialization statements within an initializer block. The last thing you need to know is that we have a concept of anonymous objects in Java as well. So I would just show this to you. This is in the latest Java 10 version, and you may want to use this sometimes. So for example, I would just use a var keyword over here. This var is just going to show that, this is a new data, and I would just call it anonymous object, anonymous obj equal to, we would use the new keyword. And then over here, since I want to create an object, right? So what is the class from which I would make the object? So since we already defined attendance and constructors, but here we have an anonymous object and we do not want to actually assign it from a proper class which we have created, we would just use the object class of Java. And in this, with a curly open and close brace, here we can define the various data members and methods which we want. So let's say, for example, I would just write subject equal to, and I want to use this value of, let's say, enter java dot class name over here. And this subject is going to be string, right? Because the class name is string. Let's not forget the semicolon over here. And let's just save this, and let's try to print now from this anonymous object the subject which we just assigned. So anonymous obj dot subject, and when I save this and let's just comment this out and I print this, now it says Java. So correctly, from the enter Java, the class name is assigned to the subject of this particular object, which is actually, just an anonymous object. It is not from a class which we have just defined. We just defined the class or the details over here right now, and we are able to actually have a live object with us. So here, what is happening is that with the new keyword, we do not have any blueprint or any class over here. We are directly creating an object. So this is something which you might want to use sometimes, but otherwise we are good with all the other syntax which we just studied.